All right, we're back for our last lesson of the week. We're going to be talking about standard form of a quadratic equation, which we already know what standard form is because we used it when we were solving. I know some of you are probably tired of my dad jokes, but I'm a dad, so I'm going to tell you another one. It's actually my favorite one. How do you make a tissue dance? You put a little boogie in it. Aha, that's kind of gross. Okay, standard form of a quadratic equation. Again, we've done standard form quite a bit. That's going to be our ax squared plus bx plus c. Sometimes our book calls it general form. I don't know many people that actually call it general form. We usually call it standard form, but either way, it's pretty much this. Well, it is the same thing. So when we did quadratic formula, when we were solving by factoring, we always put our equations in standard form. The only difference for graphing is instead of equaling 0, it's just our f of x or y equals out front. Just like when we did factored form, the a value is still going to tell us the same thing. So I'm not going to spend a lot of time going over the a value, but we know if a value is positive, right? Positive means the graph opens up, and if it's negative, the graph opens down. As far as the c value, right, our constant at the end, what does that tell us? Well, we're going to go ahead and look at a quick Desmos activity again, like we did the other day, to explore a little bit and hopefully help you have a better understanding of the c. So right now I'm going to leave the a value as 1 because we know the a value just makes it go up and down. The b value we're not going to deal with at this point. We're going to do that when we do transformations another time. But our c value, if I change the c value, what's happening to the graph? Right? It's moving up and down. So if I move my c to positive 2, you might notice that my y-intercept is positive 2. If I move my c to 4, my y-intercept is 4. Now, if I change the b, it's actually going to move the graph left and right. But if I move the b, let's see if my y-intercept changes at all. Okay, I moved that quite a bit, but my y-intercept is still 4. Right? If I change my b to something else, my y-intercept is still 4. If I change my c value now, if I change my c to negative 1, where's my y-intercept? It's at negative 1. So the point that I'm trying to make is our c value, whatever we put as our c value, that will always be our y-intercept. So the c value, going back to the lesson, our c value is always the y-intercept. Okay, so just like factored form gives us the x-intercept, well, both x-intercepts, standard form will give us the y-intercept. And then when we learn vertex form next week, guess what that's going to tell us? The vertex. All right. So hopefully you can read these. I'll say them as we go just so we can make sure we know what we're looking at. But this one is negative 3x squared plus 2x minus 9. And the question is, does it open up or down? Well, our a is negative 3. So if our a is negative, this graph opens down. If the graph opens down, does it have a maximum or a minimum? Well, it changes direction up there, and that is a max. And then the y-intercept. How do we know the y-intercept? Well, if it's in standard form, we simply look at our c value, which in this case is negative 9. So our y-intercept is 0, comma, negative 9. The c value is always our y-intercept. What if there is no c value? Well, if there's no c value, then it's really 0. So what is our y-intercept? 0. That's all that means. This one is a positive x squared. So our a is positive 1, which means the graph will open up. And if the graph opens up, that means we have a lowest point, so it has a minimum. This next one is negative 0.5 for the a. So if our a is negative, the graph will open down. And And again, if the graph opens down, we have a maximum. And then our c value on this problem is positive 10. And because it's in standard form, we know that our c is our y-intercept. So it is 0, 10. So it's not like factored form where you have to do the opposite, right? It's whatever number is there, that is your y-intercept. And then final example, we have 5x squared plus 3x. Our a value is 5, which is positive, so it's going to open up. If it opens up, we have a minimum. And then our c value on this one is right here, which is 0. So our y-intercept is, once again, 0, 0. Pretty simple. All right, the axis of symmetry, when we did factored form, we were able to go halfway between the roots, right, to find the axis of symmetry. But in standard form, we can't do that because we don't know what the x-intercepts are unless we factor it. But there is a formula that we can use to always find the axis of symmetry, and that is x equals negative b over 2a. That seems kind of familiar. Where have we seen negative b over 2a? X equals negative b plus or minus the square root, blah, 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 all over 2a. So that first part of the quadratic formula, the negative b and then over 2a, that is actually our axis of symmetry. And then when we added and subtracted this number, that got us to our x-intercepts. So the axis of symmetry plus one number gave us our intercept on the right, and then the axis of symmetry minus the number gave us our x-intercept, on the left. But anyway, long story short, to find the axis of symmetry, negative b over 2a. So to find this axis of symmetry, I label my a as 2, b is 8, c is negative 12, and I know it's x equals negative b, which is 8, over 2a, 2 times 2. So that's negative 8 over 4, which means my axis of symmetry for this problem is going to be x equals negative 2. It all connects together. Okay, finding the vertex. Well, we know that the vertex is always on the axis of symmetry. So to find our x-coordinate of our vertex, we just do the formula for the axis of symmetry, negative b over 2a. So this is a problem we just did, right? And when we did negative 8 over 2 times 2, we got negative 2. So my axis of symmetry was negative 2, right? Let's double check. Yep, there it is, negative 2. My axis of symmetry is negative 2, which also means the x-coordinate of our vertex has to be negative 2. Well, now that we know the x-coordinate, how can we find the y-coordinate? That's right, we can use math. I'm going to take this x value and I'm going to plug it in there. And I'm also going to plug it in there because my x is negative 2. So I know that y equals 2 times x squared, so that's negative 2 squared, plus 8 times x, so 8 times negative 2, and then minus 12. You do have to be pretty careful with your order of operations. We always do exponents before multiplying, so you don't want to multiply these together and then square it. So I'm going to do negative 2 squared, which is a positive 4, and then I'm going to multiply that by 2. Simplify this out. So 2 times 4 is 8. 8 times negative 2 is a negative 16, and then minus 12. 8 minus 16 is negative 8. And negative 8 minus 12 is negative 20. So again, we found our x-coordinate by using the axis of symmetry formula, and then we found the y-coordinate by plugging x into both parts of the equation. Okay, we're going to do 2 more examples just to help you hopefully process through this. Determine the axis of symmetry and the vertex. So axis, we know it's going to be x equals negative b over 2a. I know that my a is 1, my b is negative 8, and my c is 7. So I'm going to do negative b, negative 8, divided by 2a. A is 1. Negative 8 is positive 8. 2 times 1 is 2. And 8 divided by 2 is 4. So my axis of symmetry is x equals 4. Okay? Well, if I know my axis of symmetry, which part of the vertex do we already know? If we know the axis of symmetry, we know the x of the vertex. So the x of my vertex is 4. And then how did we find the y-coordinate? That's right, we plugged x back into the equation. So I'm going to plug in 4 for both x's. So I get y equals 4 squared minus 8 times 4 plus 7. So again, I put in 4 where the x's were at. 4 squared is 16 minus 32 plus 7. 16 minus 32 is negative 16. And negative 16 plus 7 is negative 9. So our y-coordinate is negative 9. I can move that on up. And we get a vertex of 4, negative 9. Okay, one more example of this. My axis of symmetry, negative b over 2a. I know my a is 1, my b is 2, my c is negative 15. So if I plug those in, I get negative 2 over 2 times 1. Negative 2 is negative 2. 2 times 1 is 2. And negative 2 divided by 2 is negative 1. So my axis of symmetry is x equals negative 1. To find our vertex, we know that the axis of symmetry, x equals, is also the x of our vertex. So our x is negative 1. And then how do we get the y value? That's right, you're getting the hang of this. We plug in our x into both of those x's. So we get negative 1 squared plus 2 times negative 1 minus 15. Again, parentheses help us to avoid mistakes. If you do negative 1 squared in your calculator, it might say negative 1. But we are smarter than that. If we use parentheses, it reminds us that we're doing negative times negative, which is a positive 1. 2 times negative 1 is negative 2. And then our c value of negative 15. Right? So we know the y-intercept is negative 15, side note. 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. So our vertex is at negative 1, negative 16. So axis of symmetry, find that first. Once we find the axis of symmetry, we know we have half of the vertex, and then plug that x in to get your y. All right, a little bit of graphing here. This equation is given to us in standard form. The two things we know right away is because a is positive, it's going to open up. And our c is 12, which means our y-intercept will be 0, 12. I went ahead and put the factored form, right? So you get a little review of factored form. If we factor this problem, it factors to x minus 2 times x minus 6, which means our zeros, or x-intercepts, are the opposite. So our x-intercepts are 2 and 6. So I can put those on my graph. 2 and 6. So I'll put an x-intercept at 2 and x-intercept at 6. Well, the axis of symmetry, I could do my negative b over 2a. Or, if my zeros are 2 and 6, where does the axis of symmetry have to be? It has to be halfway between, which would be at 4. So I know my axis of symmetry is x equals 4. Right, if I did the negative b over 2a, I would get negative 8 over 2 times 1, which which is 8 over 2, which is 4, right? Just in case you didn't believe me, right? If we do negative b over 2a, or if we find halfway between the x-intercepts, it's still x equals 4. And then our vertex is always going to be the x of the axis of symmetry. And then how did we find the y-coordinate? Well, we went back and we plugged it in. And you actually could plug it back into factored form, but since we're doing standard form today, I'm going to plug it back into the standard form. So I'm going to take 4, I'm going to plug it in for x and x. So I get 4 squared minus 8 times 4 plus 12. That gives me 16 minus 32 plus 12, which is negative 16 plus 12, which is negative 4. So my vertex is at 4, negative 4. So I can go down to 1, 2, 3, 4, negative 4. And put that point on the graph, positive 4, negative 4. That's my vertex. And then the last thing that I can now add to my graph is I know the y-intercept is 12 because my c value is 12. So I can count all the way up to 12. 1, 2, 3, 4, 5, 6, 7. And I can put a y-intercept up at 12. Actually, where can I put one more point? Well, let's think about it. If this has to be symmetric, if this point is 4 spots away from our axis of symmetry, that means if I go 4 more spots to the right and go over to 8, 12, I have to have a point there. And so now I can connect these points in a nice U-shaped parabola, and we have graphed that problem. One more similar example. Again, it's negative, so we know it's going to open downward. Our c value is 20, so we know the y-intercept is 20. I went ahead and put it into factored form so we could find our zeros. If this is x minus 5, then one of our intercepts is positive 5. And then if this is x plus 2, our other intercept is negative 2. So 1, 2, 3, 4, 5, and negative 2. I can put my x-intercepts at those 2 spots. I know it's going to open down. Now the axis of symmetry, we could count halfway between negative 2 and 5. Or if we use our standard form, our axis is negative b over 2a. So that's going to be negative 6 over 2 times negative 2, which is negative 6 over negative 4. And if you divide those, you get 1.5. So our axis of symmetry is 1.5, which if you counted to the middle from these 2 numbers, you would get 1.5. So our axis of symmetry right about there, which means our vertex has an x of 1.5. And then how do we find the y? Well, we take our x, so we plug it in. Gonna get some tougher numbers here, but that's okay. I got a calculator if I need it. I'm going to do negative 2 times x squared plus 6 times 1.5, and then plus 20. 1.5 times 1.5 is 2.25, and then times negative 2 is negative 4.5. 6 times 1.5 is 9. And then we add that 20. Negative 4.5 plus 9 is positive 4.5. And then add that with 20, I get 24.5. So I know my vertex has a y-coordinate of 24.5. So I'm going to go up to 24.5. That is where my vertex is going to go. And then the one additional point that we know for sure is that our c value, since it is 20, that means our y-intercept is at 0, 20. I'm going to estimate right about there. And then I know if I have a point here, I have to have a symmetric point over there. And I can connect my dots in a nice U-shaped curve. And we've got a graph of our quadratic. All right, I will do one more of these. Sure, why not? If our factored form is negative x and x plus 4, the 0 that goes with this one is literally 0. So one intercept is at 0, 0. Our second intercept is at -4. If we look at our A value, it's negative, so we know the graph's going to open down. And then if we look at our C value, it is 0, so we know the y-intercept is 0, 0. But if I put my zeros on the graph, so 0 and -4, axis of symmetry, I can do -b/2a, or I can recognize pretty quickly that halfway between 0 and -4 is -2. So my axis of symmetry is x equals -2, which means my vertex has an x of -2. And then to find the y value, I'm going to plug my x of -2 into the original equation. And so I get negative, plug in my -2 squared minus 4 times -2. Lots of negatives, be careful. -2 squared is +4, but then +4 times a negative is -4. And then -4 times -2 is a +8. And if we add those together, we get a +4. So the vertex is -2, 4. So -2, 4. And then we said our y-intercept was 0, which we already have a point there. So we have enough to connect our dots in our U-shaped parabola. Again, it's upside down because our A is negative. If our A is negative, we have a maximum. And then our C value is 0, so our y-intercept is 0. I think that's probably pretty good for those. Let's go ahead and move on to this problem. Analyze each quadratic function. Identify the quadratic function as general form, standard form, or factored form. So if we look at it and it has the two sets of parentheses, we know that this one is going to be factored form. But if it's our ax squared plus bx plus c, this is going to be our standard form. Now, I'll be honest, if you gave me standard form like this, I wouldn't be too happy. I would expect you to rearrange it into -4x squared plus 12x plus 16, but it's still standard form. Does the quadratic have an absolute maximum or absolute minimum? Well, this one has a negative a value.